On this Ram 2500 HD with the 6.4HEMI P0308 means the PCM is seeing a misfire on cylinder 8. The truck may run rough, stumble under load, idle unevenly, or flash the MIL if the misfire is severe. Broadly, this kind of code can come from ignition, fuel delivery, air leaks, engine mechanical problems, valve lift or cam-related issues, wiring, connector problems, or much less commonly, the PCM. The key is not to jump straight to a coil or plug. Work the path in order and prove where cylinder 8 is losing combustion. Before testing, understand how the PCM is deciding this. The misfire monitor runs only when the right gates are met. Fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F, or if the start temperature is below threshold. When engine temperature reaches 21 degrees C, 69, 8 degrees F, engine speed is between approximately 400 RPM and 6,200 RPM, and the monitor is disabled during a decel fuel shutoff event. The code sets when crankshaft speed variation between cylinders exceeds a calibrated value based on engine speed and load. Start with the basic system checks. Turn the ignition on, record all codes and captured operating data, then reproduce the captured conditions. During the drive, pay attention to when the misfire shows up, because that information matters later. Watch the downstream O2 sensors while the misfire is happening, and use the misfire monitor to confirm whether cylinder 8 is showing excessive misfires right now. If it is not active, treat it as an intermittent condition, instead of forcing the rest of the pinpoint path. Next, look at the other recorded codes. If there are active or pending codes tied to fuel, ignition components, air handling, VVT or VVL, deal with those first. If there are no related active or pending codes, continue with the cylinder 8 misfire path. Now do a hands-on inspection. Look for belt or pulley issues, poor sensor mounting, connector and terminal problems at the crank, cam, map, throttle body, injector, coil, and PCM power or ground areas. Also look for vacuum leaks, intake or exhaust restriction, internal engine concerns, moisture on ignition parts, fuel level or fuel quality problems, and operating conditions like bogging or overload. If you find a problem here, repair it and verify the repair before moving deeper. After the visual inspection, check the engine and intake manifold for vacuum leaks. A leak can affect one cylinder or multiple cylinders depending on where it is. If a leak is found, repair it and verify the repair. If no leak is found, check the fuel for water, wrong fuel type, old or contaminated fuel, and low fuel. Also check for the proper ethanol level in the gasoline. If the fuel is the problem, replace the fuel and if needed, flush and clean the fuel system, then verify the repair. If air and fuel quality check out, move to the injector balance style test. Safely relieve fuel pressure before opening the system, because the fuel system stays under constant pressure even with the engine off. Install fuel pressure decay tester 8978A to the fuel rail. Key on. Let pressure reach maximum and stabilize, and record that as starting pressure. Actuate the cylinder 8 injector while watching the gauge and record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder. Skipping that can damage the engine. Repeat the same process on several known good cylinders, always starting from the same starting pressure, then compare the ending pressures. If cylinder 8 stands out with too small a pressure drop, check for debris in the fuel rail or injector and repair as needed. If the pressure drop is too large, suspect a faulty or fouled injector, then verify the repair. If the injector pressure drops are about the same, remove the fuel pressure tester, reconnect the fuel lines, and check spark at the ignition coil for the misfiring cylinder. Turn the ignition off, remove the cylinder 8 ignition coil, reconnect the coil harness connector, disconnect the cylinder 8 injector connector, install a spark tester on the coil and crank the engine. You are looking for a crisp blue spark. If the spark is not crisp and blue, skip ahead to the coil feed and control circuit checks. If spark is good, keep going with plug and cylinder inspection. With the ignition off, remove the cylinder 8 spark plug and inspect it closely. Look for cracks, carbon tracking, oil fouling, coolant fouling, excess fuel fouling, gap out of specification, or a loose or broken electrode. Also look for signs of oil or coolant in the cylinder. If any of those plug conditions are present, replace the spark plug. If oil or coolant is in the cylinder, diagnose and repair the cause, then verify the repair. If none of those conditions are present, continue. Next, run a compression test on all cylinders and compare the known good cylinders against cylinder 8. A compression or valvetrain problem often shows up across operating conditions and usually has the highest misfire count on the affected cylinder. If compression is not within specification, perform a cylinder leak down test to separate valvetrain issues from combustion chamber issues, repair as needed, and verify the repair. If compression is within specification, exchange the cylinder 8 spark plug with a known good cylinder, or replace the plug if access makes swapping difficult. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace that plug. If the misfire goes away after replacement, verify the repair. If it does not move and does not go away, continue. If the plug and compression checks do not identify the fault, clean carbon from the valvetrain and combustion chambers using Mopar combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, reproduce the captured conditions, and watch the misfire monitor. Carbon on valves and guides can cause misfires under many conditions and is often more noticeable at cruise or under heavy load. If the misfire does not return, the cleaning corrected the fault and the repair still needs to be verified. If it returns, check engine oil level and condition before going farther. Look for mechanical tolerances out of specification, oil pressure out of specification, low oil level, the wrong oil filter, dirty or deteriorated oil, contaminated oil, incorrect viscosity, or aerated oil. Missing that oiling check can lead to misdiagnosis. If any of those are found, repair the oiling or mechanical condition and verify the repair. If the oil and mechanical checks pass, consider VVL only when the symptom pattern supports it. If the misfire occurred when engine speed exceeded 5,000 RPM and VVL is suspected, check VVL operation. The path notes that a rocker arm stuck in low lift mode can cause a misfire at or above approximately 5,000 RPM, and that certain VVL faults may or may not come with a VVL code. Before checking rocker arms, make sure the solenoid O-rings are not missing or damaged and that the solenoid is not leaking when off. There is an important caution on this branch. The cylinder-specific VVL description calls out cylinder 1 hardware, while this episode is for cylinder 8. Do not generalize that detail to cylinder 8 without confirmation. Pause, recheck the earlier diagnostic path, and avoid guessing. If no VVL issue is found, visually inspect the camshaft, rocker arms, and springs for excessive wear or broken parts. Worn cam lobes, rocker arms, or springs may not always show up during compression testing. If defects are found, repair as needed and verify the repair. If none are found, move to the harness and connection checks unless the earlier no-spark path sent you into coil circuit testing. If the spark test failed, check the ASD relay output at the ignition coil connector. Keep clear of the fan, belts, and pulleys while the engine can operate and avoid loose clothing. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay output circuit at the coil connector. If the light does not illuminate brightly, stop the actuation and repair the open or short to ground in the ASD relay output circuit between the PDC and ignition coil connector, then verify the repair. If it does illuminate brightly, test the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the ignition coil connector and crank the engine for 5 seconds. If the light blinks brightly, replace the ignition coil and verify the repair. If it stays on constantly, check the control circuit for a short to ground. If it stays off constantly, check the control circuit for an open. For a coil control circuit short to ground check, turn the ignition off, disconnect the PCM-C2 connector, and install the GPEC Diagnostic 10436 adapter on the engine harness side. Do not probe PCM harness connectors directly. That can damage terminals and create poor terminal-to-pin contact. Check continuity between ground and the coil control circuit at the ignition coil connector. If there is continuity, repair the short to ground and verify the repair. If there is no continuity, continue to the final connection checks. For an open circuit check, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is not below 3.0 ohms, repair the open or high resistance and verify the repair. If resistance is below 3.0 ohms, continue. The last step is a careful connector and terminal inspection. Disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Look for poor installation, broken locks, corrosion, water intrusion, seal damage, bent terminals, overheated terminals, push-back terminals, spread terminals, and weak terminal tension. Repair anything you find, then reconnect everything fully and make sure the locks are engaged. Erase the codes, operate the vehicle under the monitored and set conditions, and read the codes again. If P0308 returns after those checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been corrected. Takeaway: prove the active cylinder 8 misfire first. Separate fuel, spark, mechanical, and control circuit causes in order, and keep final verification separate from testing. For more diagnostic training, visit stepdiagnostics.com.